Hello everyone, welcome back. I hope everyone is suitably caffeinated and I appreciate lunch is next as well, so I'm going to try and make this as interesting as possible. So we're going to be learning today what is a service mesh and do I need one? Now, a few of you may notice I've actually stuck in the cloud native bit there. The original title didn't have the cloud native, but I think we've been hearing quite a bit about cloud native over the last couple of days and it's super important. I think the expectations and reality are somewhat different between, what we're sort of pitched, as in these are the kind of the perfect version of cloud native, and what we as engineers have to put up with. The pitch is we carve up our applications, loosely coupled SOA, bounded context, put it in containers, ship it, and we are good to go. Yeah, cloud native in a nutshell. The problem is many of us have legacy apps, or just apps, money-making apps, that are often a bit of a tire fire. The snag is when you put tire fires in a container, what you actually get is literally tire fires in a container, And you'll notice the firefighters in the bottom there, this is what we call as DevOps in our industry, This is how I make my money as a consultant here in Germany, in the UK, and also in the US as well. So the key takeaways today, I like to prime people with what we're going to be learning. And fundamentally, we're going to be looking at a service mesh. It is a dedicated infrastructure layer for making, at the moment, service-to-service communication safe, reliable, observable, and configurable. There's also going to be some messaging stuff come in. People looking at Kafka. Service meshes are also sort of encroaching on Kafka's space now, or rather, not encroaching, but being combined with Kafka. So not only can you observe service to service, but you can observe messaging in your infrastructure in general. I think this kind of thing is valuable as we move from deployments of kind of complicated systems. I'll explain more by what I mean by the word complicated. Like things like monoliths, classic SOA, that kind of thing. As we move to complex cloud-native systems, microservices, serverless, fast, all this kind of good stuff. We heard it last night. If anyone came along to the talk last night with the panel last night, be very careful. This is new technology. Owen, who did a talk before me, said the same thing. We are exploring this space. There's a lot of pain, potentially, with microservices, particularly around communication, hence why service meshes are being created, but this is a super new space. Not much of the technology is production ready. I've worked with clients that are using it in production, but they're taking the risks on board, knowing that this stuff, other than Linkerd, a lot of the technology you'll see today is not really battle-tested, and this can be quite a challenge. This is me. I love getting involved on the Twitters, at Daniel Bryant UK. I work as an independent tech consultant. For my sins, I am writing a book on continuous delivery in Java. That one's been going for a while. I think last year at this conference, I talked about that. I'm still working on it, but writing a book is hard. I'll tell you that, It's a lot of fun, but it's hard. So I work on sort of the tech side and the organizational side. I think last year I actually did an organizational talk, but this one is going to be very much tech-focused. Don't get me wrong, as you hopefully heard from all of us at the panel last night, the organizational stuff is probably more important than the technology. I'll say it again. The culture, the organizational stuff is probably more important than the technology, but today this is a tech-focused talk, all right? So just kind of caveats that have been said. Setting the scene. So we've kind of moved. I started my career in the 90s, roughly, I know we've been developing software since probably the 50s or 60s, but I started my career then. It was kind of monoliths and single language, these kind of things. Cloud didn't really exist back then, and we optimized for stability. As we move through to 2000s, famously in 2006, Amazon released kind of their S3 and SQS, and the cloud has just gone from there. I was kind of, this time, as a full stack developer, because I did Java and JavaScript. I was full stack, And now that one's kind of, that term has evolved even more now. But we had very much a focus on monoliths, coarse-grained SOA, and kind of smart pipes like ESBs and MQs. Have people worked with enterprise service buses in the audience? Appreciate I might be a little bit old. Not everyone's, awesome, a few hands, great stuff. So I'll cover some of that later on as well. 2010s has been make everything smaller. Fundamentally, with microservices, it is just about modularization. Fantastic paper from David Parnas, written in 1973, 74, talked about modules, and you can literally read the paper and replace in your mind the word module with microservice, and everything is good. It's about cohesion. Chris talks a lot about this, Chris Richardson. It's about cohesion. It's about coupling, yeah? But we are using the network boundaries to enforce those principles. We're creating network boundaries around our services. We're moving more towards dumb pipes, so REST, HTTP, decentralized communication. We're bringing in many different languages. Not just Java, not just JavaScript. There's often Go and Ruby and other things now. And everything is software defined. Yeah, for better or worse, I used to rack and stack, servers. Now I do everything via an API, via Terraform, Ansible, these kind of things. And accordingly, it's making our teams change to more cross-functional, general-purpose teams. I've heard it called FinDev, kind of business-aware developers. Google's SRE, site reliability engineers in the middle, and then platform teams running things like Kubernetes, ECS, Mesos, that kind of thing. Now, as we've moved through these things, I think, and I'm borrowing from the Cynefin model. If anyone's interested, the Cynefin model is a model of how we, as humans, deal with complexity. Yeah? And I think, comparatively speaking, we've moved from a relatively simple era, and I'm not saying it was simple, but in the grand scheme of how we as developers, how we as architects build systems, we've moved from simple to kind of complicated and ultimately to complex. And the jump between complicated and complex is very big. Yeah? Complicated systems, you get cause and effect, and it's very easy-ish to reason about them. Simple systems are literally just simple. The jump between complicated, where we have cause and effect, to complex is big in that you have emergent systems. There's many more components involved. Things are moving at different paces. It's hard to, as humans, our sort of cognitive abilities, it's hard to understand what's going on sometimes, particularly with things like database triggers, with serverless, all these kind of things. So be aware that that jump is quite big. We're trying very much to avoid the fourth area in Cynefin, which is chaotic, yeah? And I encourage you, if you're keen to understand what we call sense-making more, how we as humans understand and model complexity, the Cynefin framework, it's a Welsh word, is well worth looking into. But I think we are very much here, and I'm kind of wrapping all these things up, and many of us have talked already at the conference about this, as being kind of the cloud-native space. Cloud-native in quotes. I think it's a useful word. I think sometimes like microservices, DevOps, cloud native, it's very easy to misunderstand the word, and unfortunately when a word gets popularized, it gets abused by vendors and or just all of us, to be honest. But I like the term cloud native for bundling a bunch of things up. And I think what we're going to focus on today is the dumb pipes and the decentralized communication. Yeah. Has anyone heard of the 8 fallacies of distributed computing? Yeah, few, awesome. So this totally got me and I think it's also the 8 fallacies of cloud native. When I first started developing on Amazon's and deploying on Amazon's code, all these things I found out. Yeah, and this was a nice paper. I've referenced some stuff down the bottom there. You can read more about these 8 fallacies. But I think all of us as engineers, particularly if you've come from the monolithic era, maybe using PaaS or deploying on infrastructure that you own, it's very easy to be burned by these kind of things. And in fact, as a consultant, the most common kind of response I see to when I start pointing out these things to developers, I get called in, something works in dev very different than it works in production, not quite sure why. And I often say, everything in Amazon and any cloud is over the network. Block stores, databases, everything is going over the network. And the general approach to how we deal with that is this, yeah? It's kind of, that'll be fine, yeah. Where in reality you have to code or at least put your infrastructure in a way that we can kind of prevent some of these problems. So what do cloud-native comms look like? In cloud-native communication, I'm a big fan of Christian Poster's work. Christian comes from the Java EE, ESB, MQ days. He's worked for Red Hat, and he worked for Netflix, and he worked for a bunch of different companies. He's got a perspective on classic technologies and more modern technologies. So I'm a big fan of Christian's work. He talks that in the cloud-native world, services communicate over an unreliable network. Anyone who's used Amazon, Azure, Google for any period of time, you just get split-brain scenarios, you get networks dying, you get latency, these kind of things. Interactions are non-trivial. We've got microservices, we've got serverless frameworks. How are they interacting is not always trivial. Sorry, is non-trivial. But there is lots of value in understanding the network, both at a static kind of snapshot, how are all my components linked up together, and both dynamic. How at runtime does the network behave? We're quite good as architects understanding the static snapshot of the network, but the dynamic part is where we're not quite so good at yet. The application is ultimately responsible for handling any problems. Yeah, so if something goes wrong in the communication, you can do things at the infrastructure level, but ultimately your application has to deliver the user experience. Yeah, if something goes wrong, do you hide it from the user? Do you show a stack trace? You know, all these different kind of things. So we've been here before, though. You know, these are not kind of similar problems popped up. People have tried to do RPC with queues. I don't know if anyone's tried to do that back in the day. We tried to make their communication more robust, but then we introduced latency, and understandability was hard of these things. We brought in these magical enterprise service buses. This is Christian's work. Actually, Christian's great graphics here. And the problem with the enterprise service bus is not only was it a sort of single point of failure, but we also put business logic in there. They become kind of smart pipes. And when we were deploying services, we often had to deploy our code and something to the ESB. Yeah? And that coupling is bad. It reduces our flexibility. Also, we're seeing the same kind of things with API gateways. This is a presentation I did a couple of years ago, the deadly sins of microservices. And I've seen people try and put API gateways as the backbone for their communication framework within the network, and a bunch of other things. They basically think, if anyone's used Zool, Netflix tech, Zool is awesome, but it's very easy to inject dynamic code in Zool, and then you have that problem again where you've got some business logic in the gateway and some business logic in your code. And the more the business logic is spread out, the harder it is to work with. So be cautious of these kind of things. You know, one thing I would mention is service meshes are very much focused on what we call the east-west traffic. The traffic within your data center, the traffic within your sort of services. Things like API gateways are focused on what we say as the north-south traffic, the ingress and egress. So ingress into your application, egress to maybe to external services. So service meshes are focused purely on the east-west, purely within kind of the boundary, at least at the moment they are anyway. So I, like many people, I work with ESBs. We were super keen when we started developing microservices to not reinvent the ESB pattern and not use an ESB. There are some good ESBs. MuleSoft do a very nice open source lightweight ESB, but some of the vendors I will not name because I'm being recorded, but some of the vendors do quite heavyweight ESBs that maybe lock you in. So I was very keen, my team and I were very keen to avoid these kind of things. But we had a bunch of problems. The first one with our microservices, this is back in 2014, was service discovery. Yeah. And service discovery, we use something, we iterated, but eventually we used something like Smart Stack. I don't know if anyone's bumped into Smart Stack by Airbnb. You kind of have your application here. You were running Nerve, like almost as a sidecar type process, or as a process on maybe an EC2 instance. And your application used to link up with Nerve and Synapse to register where it was located, where on the network it was located. And then this application could use Synapse to discover, oh, here's how I talk via a local HA proxy in this case. We used NGINX, I think, at the time, and we used a bunch of other tools as well. We had our application talking via the proxy. So this is like an EC2 instance here. Apologies over this side. So the boxes are like an EC2 instance, say, and we were talking via an HA proxy or an NGINX process that was on the same EC2. We had many applications talking via the HA proxy, the NGINX, and if the service we wanted to talk to was on the same EC2 instance, it was smart enough to use the loopback adapter, and you could just use localhost. It was quite a nice bit of kit. Our approach to fault tolerance was pretty much this at the time, again, yeah, and we got burned. We were primarily a Java stack. We were using Spring at the time, so we leveraged Netflix OSS. This is before it became Spring Cloud, but we used Hystrix, and we started looking at things like Ribbon, and it was great. And that project was pretty good, but then we moved on to another project where we were using Java and Ruby. And the problem was all the Netflix stuff is library-based. So the Java implementation of fault tolerance was quite different than the Ruby implementation of fault tolerance. And if you're all in on Java or all in on Ruby or whatever, picking a library is great. But if you're using polyglot languages, which more and more of us are, this is a big challenge. And this is why with service meshes, we're trying to push some of the functionality from the likes of Netflix OSS, which is great tech. But remember, it's at least 5 years old now. We always hear the echoes of where Netflix have been. It's great tech, but we're trying to push some of this functionality down into the fabric, down into Kubernetes, these kind of things. Phil Calzado, I think, has explained this really well. And he talks about, we put a lot of our communication logic into our application itself. We're using libraries like the Netflix stack. And we keep the networking stack, our HTTP drivers, our TCP drivers separate, but we're baking a lot of these things in, and it causes problems when we need to update these things or when we're doing different languages. We kind of want to pull them out. Yeah, we kind of want to have our services, completely separate from our actual, say, circuit breaking and service discovery, these kind of things. And ultimately, this is what we've got with things like Envoy and Istio and so forth. We have this sidecar model, and a sidecar at a general level is just a separate process that runs alongside your application. In the Kubernetes world, it's a pod and you have multiple containers, but we've run sidecars on EC2 and so forth. It's just a separate process that is aside your main application. We're assuming that the communication is secure within this boundary. So my service, A, wants to talk to B. It does so via the sidecar, but this communication hop here we're assuming is secure. There is some stuff you can do. You can encrypt when you're going over localhost and stuff if you want to, but quite often we do make the assumption that this bit here is secure and that this is an untrusted network in the middle, so we communicate using sidecars. I'll explain more about what the sidecars can do in a minute, but that's the fundamental pattern of service meshes. Yeah. NGINX have been talking about this for a long time, so I actually first bumped into, I believe they call it the Fabric model, several years ago. The snag was you had to use NGINX Plus, their commercial offering, which is great, and several clients I worked with did use NGINX Plus, but others didn't want to, and it was quite tricky to recreate some of the service mesh functionality with the open source NGINX. But this is pretty much what we're calling the mesh. Yeah? The mesh is the thing between the services. Here we have like services talking to an NGINX Plus. That's our sidecar proxy. And it's talking, the actual proxy, the sidecar, is talking to the other sidecars. And this kind of forms the mesh. That makes sense. Christian Poster, similar kind of thing. The mesh in his world is that he has his services with sidecars or daemon processes. And again, the mesh is this kind of nebulous thing that sits in the middle and handles things like service discovery, like fault tolerance, all those things. If you're familiar with, say, the MuleSoft model of how you implement microservices, MuleSoft have different layers within their microservice stack. You can pretty much say that the mesh is the bit in between the layers. Like they have sort of some say, ingress kind of services that talk to, I can't remember the names now, but talk to like the services, and they have kind of process or back-end, maybe facades on top of legacy APIs. So the mesh is going to pretty much, in this model, sit in between all those services interacting. As a request comes in, it would go down through the stack, and the service meshes would handle various bits and pieces. If you're into your OSI model, it's pretty much operating at layer 5 and 6. It does touch layer 7, and it does touch layer 4 for various reasons, but just bear in mind that layer 7 is where we're coding. So we can only make application or business decisions typically at layer 7. So a lot of service mesh technology at the moment does not interact with layer 7. It does so for good reasons, because if you want to interact at the business level, you need a library. And we're back to the same problem with the Netflix stuff. Now, people are starting to say there's going to be perhaps lightweight libraries coming in for the likes of Istio and Envoy, because there is a lot of advantage to being able to control what happens at this level. If something breaks at this, the lower down the stack, ultimately, you can show like a failure page or whatever, but your application might know how to better handle that It might back off, or it might show an error page. As developers and engineers, we can make a decision at layer 7. So just sort of bear that stuff in mind. In terms of the actual service mesh features, so I'll run through at a high level, then go in perhaps more depth. And I do appreciate it's probably quite a lot of information coming at you. I will post the slides later, a whole bunch of links. This is a little bit of a brain dump presentation to make you aware of the good and the bad. It's generally how I roll with my presentations. But first thing with service meshes is you can normalize naming and logical routing. So you can create a mutable artifact. Liz talked about this in her talk first thing. You create your application, you reference, say, the user service there, and then you can deploy that application, that immutable container, in every different environment you have. Dev, QA, production. And the service mesh can rewrite appropriately. The service mesh in each environment can make sure you map what we call user service to an operational location, to an IP address. You can do traffic shaping and shifting, things like load balancing. We can hide services that we deploy them, but we don't release them, for example. And we can do something that's super cool, which is per request routing. So we can pick out high priority customers. We can pick out us doing test runs in production, and we can shift and shape the traffic accordingly. I'm going to have to read my notes. We can add baseline reliability. As I mentioned, when you hear circuit breaking in this context, it's not Hystrix. It's circuit breaking at the layer 4, layer 3 level. We just stop overloading a service if it's not responding. We stop overloading a service if it's doing a Java garbage collection, that kind of thing. We can increase security. One of the things I often wanted in code I created 3 years ago, was the ability to have mutual TLS. I have all my applications running in, say, Azure and Amazon, and I want within each of those services to communicate over mutual TLS. Not just client-server authentication and authorization. I want to do mutual TLS, so both parties know who they're talking to and can prove it cryptographically. This was hard until we had service meshes. I mentioned before, understanding the dynamic properties is really hard in a microservice system, in a cloud-native system. Services are being deployed, upgraded, instances are dying, we're rescheduling containers, stuff changes all the time. We as engineers need to understand what's happening. Yeah? We need top-line metrics like success rates, but we probably need some form of distributed tracing. We need to understand when a request comes in at ingress, how is it handled down through the stack? Is there one microservice that's performing really badly, for example? And something I really like, so I'll shout out a bunch of people at the end that helped me with this talk, as much as it's me presenting and all the mistakes are clearly mine. A bunch of people were very generous and lended their time to help me understand service meshes about 9 months ago. And Matt Klein, who created Envoy, works at Lyft, said at Lyft they use Envoy and their service mesh to provide sane defaults. So anyone can push anything to production, but it always communicates through the service mesh. And if you suddenly go crazy with your traffic, the service mesh will shut you down. If you're causing lots of problems in other services, the service mesh will shut you down. I thought that's a very nice way. You can clearly override it if what you're trying to do is the right thing. But he was using the team in Lyft are using the service mesh to control sort of sensible defaults when new things get deployed to production. And Lyft have been using Envoy in production now for, I think, a year or two, and at crazy volumes. For people that aren't familiar with Lyft, it's an Uber competitor, and Lyft are based primarily in the US. So I often use Lyft when I'm out in the US. So it's very much this car hailing app, but they have crazy volumes of traffic. Their app is very chatty, for example. So they have proved a lot of these concepts in production, which is very nice. Diving in a little more depth now to the actual to each of those things. First is the naming. As I sort of hinted at, you can have logical names over here, so the user service, the checkout service, and as things get sort of pushed down through the stack, our service mesh can map it appropriately in real time, as our topology, as our network topology is changing, as new containers are being spun up and shut down. Owen mentioned this actually in his talk. It was super hard sometimes it's so dynamic, it's super hard to understand what's up and what's down. So we as humans don't want to do that. We want to offload it to something like a service mesh. Yeah. Once you do offload these things to a service mesh, you can do kind of smart load balancing and load balancing internally. So a lot of load balancers, like as far as I know, I appreciate these things keep changing, but ELBs and NLBs and CLBs in Amazon, they're quite dumb in the way they do internal load balancing. With things like Linkerd, you can actually do weighted, in much more depth, weighted. You can look at latencies. You can do all these very clever things because it's a bit more in tune with things like Kubernetes and like the network fabric itself. Amazon is sometimes the lowest common denominator. I love Amazon stuff. It's awesome, of course, and I'm sure they're working on technology just like this. But at the moment, Linkerd gives you more internal load balancing options. So if you're working on a large-scale or high-performance system, first ask yourself if service meshes are right for you, because they do provide more network hops. But things like Linkerd can give you a slightly more performant experience than if you're trying to do some of the other things manually. So yeah, I've just talked here as it kind of goes down through the stack. We talk. I'm looking for my user service foo.com, and it gets mapped down to say the host and the pod and then the IP, for example. We can do traffic control. So for example, here, I think I've labeled them. Yeah, I've got service A trying to talk to service B, but we've deployed a new service B, an updated service B. Now imagine this whole thing is running in Kubernetes or ECS or something like that. At the moment, Envoy is primarily, and Istio is primarily skewed towards Kubernetes, but in theory, you could run this anywhere in the future. It will be like that. And we want to do traffic splitting. We want to kind of do a canary release. We want to have 99% of our traffic going to our battle-tested service, and we want to do 1% going to our new service. Well, we can do that via what's called the control plane. And the control plane, all of us interact with control planes all the time without realizing it, but it's the mechanism, the UI, perhaps a little bit of the brains, that interacts with what we call the data plane that does the thing. So control plane is our mechanism for interacting with the system. Ultimately, we specify a bunch of stuff. For example, some tags. We say, here, actually, I've changed the weight to 90 and 10. Istio CTL, for example, on my command line, or maybe via a UI. The pilot passes it down to Envoy, interacts when the service interacts with Envoy, it bears these things in mind and splits the traffic accordingly. So you can do canary testing. You need to be monitoring both services and both the responses to see if your new service is doing good things. Yeah, that's just Envoy there. You can do a bunch of different things, and Kelsey Hightower actually has got a fantastic video. Always got to mention Kelsey in any talk. Kelsey's just does amazing stuff. But he talked about how he was using, and I had to play with it. You can say, do request routing based and shifting and shaping based on headers. So you can have maybe beta users that are willing to put up with a slightly degraded service to get the new cool features. Or maybe on here you can say anyone who is an iPhone gets this experience. So you can do some quite funky things. With great power comes great responsibility, I might add. So be careful what you do put in all these things. But don't forget, all these configs can be version controlled. Put it into Git, do PRs, chat about these things, rather than just calling APIs and no one's really sure what state the system's in. You can be quite disciplined and set up continuous delivery pipelines to insist that what your practices are being followed, but you can version control all this stuff, which I think is really nice. You can do per-request routing. That's kind of funky. So a few clients, actually, I'm working with DataWire looking at this kind of stuff. We can identify individual requests coming in on ingress. So maybe I'm browsing production, and I can specify a certain header. Now, obviously, be careful with this stuff, because someone else could probably copy my header. But one example we've used is where we're doing kind of test traffic. We put a special header on, and we actually have in production our new service deployed. And we can route, based on that header, quite far down the stack, we can route to my test service. Yeah? Now, you have to be careful. That test service is not doing something like mutating data, or if it is mutating data of like a test database. And you can either choose to have the traffic sort of interact with the system for real, Or you can shadow. You can just basically pump the traffic in, watch what happens in your new service, but the new service never responds. The original request continues down the stack, for example. But this is very fine-grained. You can basically, per request, if you're familiar with things like chaos engineering, Netflix have got a tool called fault injection testing, FIT, and it works on this principle. They specify users they want to test faults with, they put a header effectively, and identify that user at ingress, and then they mess with that request handling down the stack. But they use technology like a service mesh to identify, who is interacting with each service. You can do things like timeouts and deadlines, pretty standard stuff. Don't forget, again, this is layers like 3 and 4, so your application is maybe not aware of these kind of things. So if a request does time out, make sure your service realizes it, or if you're not careful, you can be kind of getting stuck in a retry storm where something times out, but the service at the bottom doesn't realize it, and it keeps churning away. The user retries, and then you get another request going down, and you get this kind of crazy situation performing. Deadlines are interesting in that you can kind of deduct the time going down, but I haven't really seen this used much in production yet. It's a nice idea that we can be somewhat intelligent at each service, depending on the time we have left to handle a request, but it means we have to know about this stuff in layer 7. We have to have a library that interacts with the service mesh and can figure out how much time we've got left. And I think it's quite an advanced pattern, to be honest. I mentioned about circuit breaking, so you can, if a service is down or a service is overloaded, you can route around it, or you can stop sending it traffic. But bear in mind, this again is at the layer 3, layer 4 level. Our application isn't particularly aware in comparison with something like Hystrix. Hystrix, I can say, if this service is down, fall back to this service. The example being, if you had, say, a recommendation service that wasn't working, and you could then fall back to like generic recommendations, and then if that service wasn't working, you could just fall back to a, hey, show this page of new videos kind of thing, yeah? But this is more at the network level, almost at the wire level. We would have to do some more intelligent kind of operations in the application using something like a library, which has its trade-offs, yeah, to make a more Hystrix-like decision. I mentioned about mutual TLS. This is kind of funky, actually. So people have used Let's Encrypt, and many of the cloud vendors have got their own way of issuing certificates now. So it's much more easy than when I started my career for issuing certificates, TLS certificates. Now what we can actually do is have something like a service mesh handle that all for us. It can rotate certificates, it can apply to Let's Encrypt and get new certificates, and we can guarantee over the network that service A is talking to service B, and service B is talking to A. Mutual TLS, not like in the normal web, like client-server model, when we don't have mutual TLS. Yeah, we typically have one-way kind of TLS. So this is quite nice. Inside our infrastructure now, we can guarantee services are who they say they are. It's kind of nice. So following on from that, we can do things like communication policies. Because service meshes can inspect the wire level traffic, not only can you do basic stuff on HTTP in terms of if a user is trying to access this endpoint, but you can also look in, say, Mongo protocol. You can look in the Kafka protocol. And service meshes are moving more and more towards this space where they are the one true source of how we secure a system. Yeah, in terms of, because I said the one true source. Obviously, you have things like IAM on the actual assets themselves. You have you secure the container, you secure the queue itself. But in terms of user traffic, we could use the mesh to say various quotas, various metrics. There's, say, whitelists and things like that. And because the service mesh is inspecting all the traffic, it can then make decisions. And there's Calico have got a really nice blog post. If you're looking to learn more about this, and this is something I do think is going to be pushed down into the infrastructure, and we'll see this a lot more in Kubernetes and in ECS. And I know Netflix, for example, are using something called OPA to define this, Open Policy Agent. I saw a great talk, I think it was at KubeCon in Austin last year, so you can have a Google for that, where a Netflix engineer talked talked about, they're doing a service mesh-like thing internally. They're creating their own paths. And they are Netflix, don't forget. They're much bigger scale and much more specific requirements than many of us have. But they're creating their own paths, and they're using OPA to define the interactions not only between, say, the actual, when you're browsing for videos, but even when you're watching and a whole bunch of other stuff. So for them, they've got many different interactions, EC2, and there's interactions with things deployed in Mesos they're using. This is going to be their single policy for defining what user can do what, and the relationships between these users. And these like schema that says what people can do are pushed out to the service mesh, and the service mesh enforces these kind of policies at the edge of each service. A really cool thing that service meshes offer is visibility. I'm genuinely quite excited about that. There's the obvious stuff that as a service mesh looks at every bit of traffic in your infrastructure, it can do your basic, what's the network traffic, how many errors am I seeing, what's going on in the system. That's using Prometheus. This is actually me spinning up Istio locally. I'm using their sample book info application. I've made some requests, and I'm getting all the data from all the communication going into Prometheus, and I'm looking at Prometheus. But the cool thing is you also get like a service graph. Because, again, the service mesh is literally the fabric sitting amongst all the communications. You can figure out what's talking to what, and in what percentage, is it looking at a new version of the service, looking at an old version. And you can also do things like distributed tracing, which is seriously awesome. Yeah, I've tried to do stuff using Zipkin in the past in a Java stack, and it was amazing. But when we tried to introduce other languages into the stack, it soon got quite challenging, because we had to have various libraries in, say, Ruby and Python and Java all working together to preserve the correlation ID. So an ingress came in, say NGINX, we marked it as this is user interaction 157, and we need to make sure all our services pass the correlation ID down through the request handling so we could join all these things up. All distributed tracing is distributed logging, with a correlation ID that allows you to say, oh, request 157, it was handled by all these various services at various times. And you can draw it in a graph-like format you can see in the bottom left there. It's very powerful. We had a couple of problems where we couldn't figure out what service was causing latency in our stack. And when we put Zipkin in, or we actually already had Zipkin there, and we enabled Zipkin, suddenly it became painfully obvious which service was causing a problem. We then started debugging that service, and it was really, really good. Right, check my time. I've got quite a bit of material, but I think I'll skip on some. But in terms of implementations, popular ones, Envoy is kind of a very popular data plane at the moment. It's come out of Lyft. It is battle tested. It's really good stuff. Istio seems to be the control plane of choice, at least at the moment. One caveat I would mention is it's heavily stewarded by Google. If you look on the SIG groups on CNCF, so take that as you will. Google have very strong opinions, as do Amazon, as do Azure. So whether you kind of dial into the Google model of IAM, for example. But Istio tends to be the control plane, and NGINX, as Owen mentioned, and Linkerd have got proof of concepts to work with Istio, or in the future something like Istio as well. A couple of new ones popping out. There's Conduit, which is actually the second version of Linkerd. So Linkerd, the original founders of Linkerd were from Twitter. And they had something called Finagle in the Twitter stack, and they sort of took out the best bits of Finagle, or the service mesh bits, and put it into Linkerd. The challenge they've had with Linkerd is it's a JVM-based product. It's a Scala-based product. And the JVM is a little bit heavy at runtime for this kind of model where you want something sitting next to every service. So they have done a completely new open source build called Conduit. Conduit is based on Rust, or Go, kind of 2.0, effectively. Everyone's jumping onto Rust now. Rust is super cool as a language. I'm trying to learn a little bit. Awesome bit of kit. But they have rewritten their proxy in Rust. It is super alpha, as in they're definitely saying don't use it in production, but it's an interesting one to follow. And Cilium are very interesting as well. So Cilium, I've got a slightly different model. They are using Envoy to enforce quite a few interactions, but they're also using something called eBPF. And eBPF is a kernel-based technology. And at the moment, a lot of the interactions are being done by a separate process, which is not as efficient as if we can push some of the service mesh functionality into the Linux kernel itself. Yeah. Think of eBPF as kind of like Java getting compiled into bytecode and running on a machine. You can compile C in various languages into BPF and run it in the kernel itself. And when you run stuff in the kernel, it is super fast compared to user space kind of stuff. But at the moment, Cilium are leveraging Envoy heavily. I think there's going to be a migration towards a bit of both, something going on in the kernel and something going on externally as well. And it is too early to tell who is going to be a winner, to be honest. But it's a very interesting space to kind of keep up to date with. A couple of other ones. If you're using HashiCorp Nomad, check out Nelson. So Nelson is skewed towards, it's using Envoy again, but it's skewed towards HashiCorp Nomad. So I love my HashiCorp tech. I don't use Nomad, to be honest, much, but if you're using that, it's interesting. eBay allegedly are migrating to Envoy, but at the moment, and Istio, I think, but at the moment they have their own one called Fabio, which is really skewed towards AWS. So if you're looking for service meshes in AWS, have a look at this. It integrates with Console and ELB and the API, the Amazon API gateways, things like that. Oops. So putting it all together, time check. So this is Istio. And so in Istio, its kind of vision is to be an open platform to connect, manage, and secure services. Both, service to service and also messaging. And I mentioned before, proxies are the kind of data plane, how this technology actually does its actions. It uses the data plane, and Istio is the control plane operating on the proxies. The proxies are, in theory, swappable, though bear in mind that Istio was built directly with Envoy. So, and this is Matt Klein's kind of opinion, that there's a lot of tight integration between Istio and Envoy that you don't see at the moment with NGINX and with Linkerd. Not to say in the future that's going to change, but at the moment Istio is very tightly bundled with Envoy. Let's bear that in mind. This is what you pretty much get. I think we'll look at the control plane first. So you imagine we've got our services here, A and B, communicating. They're communicating via sidecars. And we have this control plane, and various different things in the control plane are responsible for different actions. Yeah. So if we're dialing into the control plane, we've got the, and I always get this wrong, but this is the pilot, and this is the mixer. And the pilot is responsible for driving, flying, the Envoy proxies. So it takes the instructions we have, it does some abstraction between whatever platform we're running on. At the moment, it pretty much is just Kubernetes. There's a couple of other things coming in. But it provides the abstraction, and it says whatever we specify in terms of routing rules, it will then pass on to Envoy. The mixer is responsible for things like precondition checking, policy enforcement, quota management, and it also does the telemetry reporting as well. And it kind of abstracts away from the Prometheus, various different stacks of recording data. So the Istio team have very much defined this as kind of like using the Unix or the Linux model. Single responsibility principles, do one thing well. If you look back, the pilot drives the envoys, the mixer is responsible for interactions in terms of telemetry and policy, and the auth section, or the auth module, is responsible for issuing certificates to secure the traffic. Nicely modularized system, yeah? There is always a control plane. Linkerd has named. It's a command line control plane, yeah? NGINX, we just saw from Owen actually, talked about this. NGINX are coming up with controller. It's their kind of control plane. So you always need a control plane. You always have a control plane. A lot of us are used to being the control plane. We would go and manually switch things and tweak things. We would deploy a script into NGINX. We are effectively the control plane then. But as systems get more complex, we need better abstractions. More and more microservices, more and more functions as a service. We need tools like this to help us manage the scale and dynamic performance, yeah? So watch this space is kind of what I'm saying there. Dialing back, the actual the data plane, the proxies itself, Envoy is super popular in this space. A lot of people are building on the Envoy technology. So I'm working with a team called Deadwire in Boston, and we're building an API gateway, or built, I should say, an API gateway on top of Envoy. So if you want, say, Envoy doing your service mesh east-west, you can have this doing your traffic north-south, your ingress traffic. Glue is super interesting. So Edit from Solo is basically creating a framework where you can repackage envoys and kind of create custom routing levels. It's kind of like a hybrid between API gateways and service meshes. It came out like 3 weeks ago. It's super new, but Edith is very smart, very tuned into the community. She's an expert in unikernels and a bunch of other really cool tech. So these kind of technologies, I think, hint at where we're going to go with service meshes. We're going to push some of it into the infrastructure fabric. Some of it, I think, will be when you, in the future, have GKE or hosted Kubernetes. I think you'll get some kind of service mesh functionality as part of that. I think some companies are going to pull it up as well into API gateways. And you're going to kind of get this cleaner level in the middle where our applications either interact with the gateway or interact with the mesh. If you want to get started, I've put a bunch of references there. Ben Hall runs a website called Katacoda. If you haven't heard of Katacoda, it's amazing. It's a browser-driven thing. You log on, you can have a terminal, and you can play around with Istio. There's a whole bunch of tech there. Ben is like awesome guy. So I often, if I'm trying to learn a new tech, and Ben has created a Katacoda tutorial, I pop onto the website. I think I might have to register. I can't remember. But you can experiment all in the safety of a Docker container running on Ben's hardware. So he's got some great Istio tutorials and play around with if you want to know more. I'm pretty tight for time now, so I'll put the whole slides up. But just a couple of things that's perhaps worth mentioning in terms of if we're looking at use cases. So what I would say is, drawing a bit more on Edith's work, again, it's really hard often to debug microservices. There's many things, the interactions are more frequent, the interactions are out of process. So I no longer, as a Java developer, can say spin up my monolith and put breakpoints in, inspect variables, modify the data. It's really hard to do that in microservices because they might be multi-language and the communication is happening out of process. So Edith's written an open source project called Squash, and I wrote up her talk actually on InfoQ, and she's pitching that service meshes are the ideal hook to do debugging. She's got a proof of concept that uses VS Code. So if anyone's familiar with VS Code, nice bit of kit from Microsoft. It's cross-language debugging. It's got GDB support. It's got Java support. It's got Python support. And it basically hooks into Envoy. And when it spots a request it's interested in, you can effectively set a breakpoint, switch into a debugger. Oh, that's the Java service. Switch into the debugger, play around with the code, and then when I'm done, I pass the request on to the next service. So I think this is a really interesting bit of technology. It's very new, but service meshes are providing the hooks to understand systems and to debug systems a little bit better. I also think for migrations, it's super interesting. So Christian's written a bit more about that. If you are looking to pull out functionality from a monolith and create a new service from it, you can use technology like this to effectively test the functionality you've pulled out. Does it match the existing functionality? And you can do that by routing traffic to both bits of functionality, only returning the old data, but doing a diff, basically, between our monolith version of that service and our microservices version. And some cool frameworks I've used in the past, like GitHub Scientist, which allows you to run experiments on different code paths, and Twitter's Diffie is very nice as well. Just finally, chaos engineering. I haven't had many talks at this conference, actually, but many conferences I've been to the last 6 months, and I'm very lucky to go to a lot of conferences, but many conferences are talking about this chaos engineering principle that's coming out of primarily Netflix, but many people are jumping on board now. The only way you can really test the resilience of a system at scale and the complexity of something like microservices is to run experiments in production, break stuff and see what happens. Yeah, and Istio is kind of jumping on that bandwagon by allowing you to manipulate traffic. You can drop requests, you can return 404s, return 500s, and you can see either in staging or production, whatever your level of comfort is, you can see what happens when you do mess with the requests. So that's kind of cool. Oh, what have I done? Sorry, guys. I've lost my mouse. Where's that gone? Sorry, there it is. Cool, so I'll just skip over a few slides. I'll put all the ones up. I'm dead tight to time there. So wrapping up, hopefully this has been a little bit of a whistle-stop tour. And as the joke goes, you can kind of watch my talk back on half speed on YouTube if I have spoken a bit too fast. So I'm totally cool with that. I'm not taking offense. As a native speaker, I do talk too fast sometimes. But hopefully you've seen that the service mesh holds a lot of promise for service-to-service communication. Even messaging in the future, I think, Kafka in particular, is becoming a target of service meshes. It's a way to homogenize all the communication we do, which is very attractive in a very dynamic, distributed, and polyglot kind of framework that many of us are working with microservices now. We're moving from these complicated worlds to complex worlds, and the technology, particularly in regards to communication, hasn't always caught up. Yeah. Kubernetes focused more on deployments than it did on runtime interaction, for example. Kubernetes is an amazing bit of kit, but they had to prioritize where they worked on. So service meshes are the missing piece in my mind of the sort of dynamic interactions, the dynamic behaviors in your infrastructure. It's a great place to hook in for observability, to do testing, debugging, all these things. Debugging microservices is crazy, crazy hard, and I think service meshes could make this easy. It's early days. A lot of the stuff coming out is open source, so we can all get involved, which I think is awesome. Word of caution, this is proper, I like to say, hipster tech. I hope that translates okay over here. And it's kind of hipster tech, yeah. I know a few clients, I work with a few clients using Linkerd in production. I've not seen Istio in production, for example. I'm working with clients that are kind of doing a POC with it, but it is very new tech. So just take care of that kind of stuff, read around, look for it as a future thing, but always know the risks if you're going to use new technology. I've worked over the last 2 years with many companies that have probably jumped on the Kubernetes bandwagon, a little bit too early. They've moved to Amazon without realizing the impact of using cloud. So be careful with these kind of things. Always use value stream mapping, understand where your bottlenecks are. The theory of constraints is super interesting. If you're not having problems with communication within your services, service meshes is probably not where you want to look. If you're having problems with deployment, maybe look more at CI/CD technology, that kind of thing. And always justify, I know most of us here are developers and engineers, but thinking more in business terms like ROI, how much money am I going to get? Things like total cost of ownership. If it's going to take me and my team a month to learn this new technology, that's a month's worth of work lost on something that could add business value. Yeah. So I'll just bookend the talk with that kind of caution on business stuff. This is my talk. All the mistakes are my own, of course, but I've really got to shout out these people: William from Bryant, Owen, Christian, Matt, Sharam, Louis, Varun. People I jumped on a call with, I chatted on Skype, and they were super helpful for helping me to understand this technology. So I really am thankful for their time. It's very much appreciated. On that note, thanks for listening. Appreciate his lunch.
There is lunch, but we have time for some questions.
Thank you very much for the talk. Awesome. What is the service mesh that you recommend taking into consideration that I have, for example, 100 microservices. I want to have visibility about MySQL, Postgres, RabbitMQ, and things like this.
Yeah, so I used to recommend Linkerd because Linkerd is the most battle-proven technology, but I am a little bit concerned, pushing on camera here, but slightly going with Conduit coming out. So Bryant have re-released Conduit, yeah. So they're clearly saying they're going to support both technologies. I'll leave that there for you. I actually say at the moment, some of the more traditional APM tooling, like New Relic, a bunch of other ones like that, App Dynamics, are probably more suited to the observability in your case. They are definitely catching up with microservice ideas as well. It took them a while, so they're very keen to work with people that are leveraging that. But my eye to the future would be on something like Istio. But if I actually had a requirement now for observability and I had the money in my pocket, I probably would look more towards APM stuff. If I'm a startup I can take more risks perhaps as a startup, yeah? I might go with Istio. Some of my clients who are startups are like, I'm going to play with Istio because we've got hardly any traffic, so who cares if it breaks? And when we go live in a year's time, we'll be in prime position. But if you're like an enterprise or you've got customers paying you money, it's quite a big gamble at the moment, because don't forget, every request goes through the service mesh. So if the service mesh goes wrong, Monzo, a UK challenger bank, talked about this. They had a massive outage with Linkerd, and it was fast. They were super generous. Like, Monzo people are amazing, and they talked about how they made it even worse and then had to roll back. So Monzo are very innovative, very hipster, and they got away with it. And you know, whereas many of us in enterprises, we can't do that. So hopefully that's a lot of words. Feel free to chat to me at lunch or whatever, but hopefully that helps a little bit.
Thank you very much.
Are there any more questions?
Hi, great talk. It seems that in the past we have talked about microservices, that it takes away the barrier, or it gives us a barrier that we have to talk to another service. And service meshes actually take away that barrier again. It makes it more easy to communicate to other services, and it feels like that we can get again to that state where we just talk to other services like we used to talk to another function or another part within my code. How do you see that?
That's a great question. So one caveat I would always say is, and I've totally been burnt by this several times, is never treat local calls and remote calls the same. I've made that mistake in Corba, in RMI, I've done it so many times. And I see this happening again, particularly with more junior developers. So I agree with you. I think it definitely, with things like the logical naming, for example, you can say user service and it kind of maps to the user service, you know, in staging or production or whatever. I'm still a little bit, I'm forming my thoughts around this, to be honest. Something, when I work with clients, I always say is, we as developers need to have mechanical sympathy. That makes sense. It's a phrase I use quite a lot. I've borrowed that from Martin Thompson, in that you need to understand just enough one level down. So if I'm a Java developer, I need to know a little bit about Kubernetes, a little bit about Istio, and that when I'm making a remote call, it might be super easy using something like Istio in comparison with something like my own custom HTTP framework or something. But there is always a trade-off. You know, that call, there is a exponential increase in the likelihood of that call going wrong compared to an in-process call. Make sense? So I always work with teams and I say, hey, mechanical sympathy, understand the 8 fallacies of distributed computing. Always know when you're making a local or remote call, and try not to create frameworks that hide that. Anyone who's worked on EJBs in the past, like local and remote kind of thing, oh, horrible, yeah? So nice idea. I think reality is the mechanical sympathy means you have to understand what you're doing. But I do think Istio adds a little bit of syntactic sugar, effectively, on top of these things that makes it a bit easier for us, which, as long as we're aware of that stuff, I think is cool.
So thanks, Daniel, for the great talk. I have a question on the overhead. So you mentioned already that we have an additional layer using service meshes. So do you have any experience, or is there any indication how expensive this overhead actually is?
Another great question. Thanks a lot. Yeah, it's a really good point in terms of there is more things involved in a typical request now, because you go via the service mesh, and particularly with something like Istio, it also often looks up in the mixer to see, I'm making service A, making a request to service B. Am I allowed to do that? Now, obviously, you can heavily cache those policy lookups, but there is often extra hops there, and there's extra hops potentially between the mesh. So my advice is always to benchmark your system and see if it impacts you. Adrian Cockcroft, I'm very lucky to know Adrian, bit of name dropping there, but I've chatted to Adrian about this a few times, and he is actually quite cautious about this kind of thing. He's saying on a lot of systems, particularly say financial systems, where we're talking like microseconds being super important, anything that adds on time is actually a bad thing. So not only have you got the network hop potentially extra involved there, but you've got something like Envoy doing a bit of processing as well. So I think Adrian's got a really good point, and I respect Adrian a lot. I always listen to what he says. The kind of clients I've worked with who are doing e-commerce systems and various other systems, for them, the benefits that something like a service mesh could provide in terms of understandability and observability, I believe in general outweigh the costs you're going to pay with communication overhead. But it's something everyone has to decide. And the best way I think to do it, to be honest, is get down and have a think. What's more important to us? Understandability and performance. For most people, it's understandability. For banking and finance, it's probably performance, to be honest. But make your decision. Run some simple experiments and benchmark. The Conduit people, for example, have benchmarked. And I think their P99 overhead, it was crazy. It's like 20 microseconds or something. It was very small, but they are obviously running that benchmark in very favourable conditions. Yeah, can't blame them. So it should be quite minimal in theory, but my advice is always check what works for you. It's a good question, definitely.
So is there one last question? There is.
Thanks for the great talk. One question I have is how you would go about to do a step-by-step integration of the service mesh into your system. Is it like that Istio works well with a non-part, let's say, which is not in the service mesh, like you have old deployments or pods running in Kubernetes that don't have this sidecar? Does this work well together somehow?
Yeah, that's a great question. So, to be honest, when I've done kind of the pre-service mesh thing, so I was very lucky to work on microservices before it became microservices, yeah, and I've worked on service meshes before they became service meshes. We often used it in migrations. So the smart stack thing I mentioned, we had like a Ruby monolith, I think, and some Java microservices. So like the communication, and as we bolted on more bits, only one part of the system used the service mesh. Yeah, that was fine, because we were only interested in that bit. But most of the people I see now looking at Istio, they're kind of going all in. And the risk is obviously higher with doing that, but the trade-off is, if you're looking at something like distributed computing, you cannot have any areas of your system that are dark, as they call it. Yeah, Google have done an awesome paper called Dapper. Google have talked about how they created this Dapper framework, which is the sort of the parent of all the Zipkin frameworks. So the Dapper paper is actually very readable. It's a very good paper, and they talked about, in order for distributed tracing, for observability and debuggability to work in this kind of context, your whole system has to be instrumented. Google are Google, so most of us aren't Google, yeah? But Google, they have very lucky in that they use something called Stubby, which is basically gRPC now, but they use Stubby and they used a bunch of other things that meant that they could put the instrumentation required in that library and enforce everyone used it. But how often does that happen in the enterprise? Let's be honest, yeah. Like if I say, you've got to use my library, it's like, ha ha ha, yeah. So I think Google and Twitter, the unicorns, as we call them, they have very different cultures than many of us do. I'm not saying they're better or worse, they're just different, yeah. So to wrap up, my answer is probably the most benefit with modern service meshes is the whole thing, but just bear in mind the challenges you might have. You've got ESBs and MQs and you've got like mainframes and all this stuff. It might not be possible to do all in one.
Thanks.
So thank you very much, Daniel. And lunchtime is now, and we see the next talk at 1:45. Thank you very much.
Thank you. Thanks,